Hello all, welcome back to another lovely day of chemistry. I thought it'd be helpful maybe if I made video lessons explaining how to do the class kicks. Keep in mind, you don't have to watch the whole thing, right? Like if you understand how to do some of the problems, great, just fast forward the video. That's the benefit to this. Go ahead and work on what you need help with. So with that, this is going to be our last one kind of before the test, so this would be a good one to practice with. So here we can see this reaction. It takes 6 potassiums to react with 1 nitrogen gas and produce 2 potassium nitrides. So let's pretend that you have 7 moles of potassium and 4 moles of nitrogen. What is the limiting reactant? So what happens a lot of times is students just think, oh, there's only 4 moles of nitrogen, so therefore that's the limiter. Well, keep in mind, we actually need 6 potassiums for every 1 nitrogen. It's kind of like if you made a grilled cheese sandwich. You could have 5 slices of bread, 3 pieces of cheese. But the bread is actually your limiter because in order to use up all 3 slices of cheese, you would actually need 6 slices of bread, but you only have 5. So keep that in mind as we're thinking through this. So if you have 7 moles, and again, I always like to solve these problems for what you have. And again, we also have 4 moles of nitrogen, so I'm going to write have. And what you can do is if you solve for one thing to another, that's going to tell you how much of it you need. So for example, if I take if I take the 7 moles of nitrogen here, so we have 7 moles, of potassium, or we have 7 moles of potassium, and I actually solve that over to nitrogen, what that's going to tell me is to use up perfectly all of this potassium, how much nitrogen do I need? Well, we can see in our reaction up here that for every 6 potassiums I can, again, quote unquote, trade, I can get 1 nitrogen in return. So if I put that in, for every 6 moles of potassium, we need, or can get, if you want to think of the Lego analogy, 1 mole of nitrogen. So if this is the case, we would find that we only need 1.1, I guess I should follow my sig figs, so 1.2 moles of N2. And we actually have 4 moles of N2. But to use up all of our potassium, we only need 1.2 moles. So guess what? That right away tells us what is our limiting reactant. Well, that's going to be our potassium here. So we can actually label off to the side, potassium is limiter, because we're going to run out of that first. So potassium is going to be our limiting reactant. So what's the excess? Well, we only have 2 reactants, potassium and nitrogen. So therefore that means that nitrogen is our excess. And so what that means down here is this question that says how many grams of potassium nitride would form. You have to base that off of your limiter. Just like if you're going to take the ingredients and make as many grilled cheese as possible. Well, if you go back to that 5 bread, 3 cheese thing, you're going to run out of bread first. So therefore, how many grams of potassium nitride? Well, we're going to start with our limiter. So our 7.0 moles of potassium. And then what we need to do is, since we're going to go to grams of potassium nitride, so grams of our product here, we need to figure out what's our trade. Well, I can trade 6 potassium for every 2 moles. Oh, I should write the word mole of potassium nitride. Sorry, my iPad's glitching here. So 2 moles of potassium nitride. But I'm not done because the question's asking me to go to grams. So going back to our Lego analogy, this is where we need to figure out, well, what does 1 potassium nitride? Well, 1 potassium nitride is going to be equal to the mass of 3 potassiums, right? Picture if you took like those potassium Legos, you took 3 of those, stacked them onto 1 nitrogen, you're going to produce 1 of that whole thing. And so what you're going to need to do is take 3 times the mass of a potassium. So we'll use our periodic table here. We can see 1 mole of potassium is 39.10 grams. Plus we're going to have the mass of a nitrogen. So we can scroll over here, see nitrogen is 14.01. And we find that the mass of potassium nitrite is 131.31 grams per mole, and that's why the 1 mole is on bottom. And that tells us that we would be able to make 306 grams of potassium nitride, but realistically I should probably follow my sig figs here, and actually this is 2 sig figs, so I need around the number 300 to 2 sig figs. So I actually get to bring in some scientific notation here. I probably wouldn't intentionally give you a problem this hard, I just kind of threw these together. And you would get 3.0 times 10 to the second grams of potassium nitride. I would generally try and avoid giving you something that tricky, but anyway, that's how you would do the sig figs for that one. Coming down to this next question here, we can see we're going to talk sodium hydroxide reacts with copper chloride, produces sodium chloride and copper hydroxide. So if you had 1.45 grams sodium hydroxide and 2.88 grams of copper chloride was your limiting reactant. I'm going to do this the same way. I have this. I have this. So I'm just going to take this one and solve for what I need. Because I don't know, I just always feel like this is the easiest way to solve for these. So to do that, all right, we have 1.45 grams of sodium hydroxide. Again, the way that you're going to solve for, because you need to figure out how much does one of those sodium hydroxides weigh. Well, that's going to be a sodium of 22.99 plus an oxygen of 16 plus a hydrogen, which is 1.01. And you would find that if you add all those together, sodium hydroxide has this beautiful mass of 40.00 grams for every 1 mole. And again, that's just like if you took a sodium LIGO, stuck it to oxygen LIGO, stuck it to hydrogen LIGO. You're still going to produce one of all that stuff combined. Then is where we have to do our trading. And some of you like the PEP thing that I did before. Just remember, this first step is going to come from your periodic table. Second step, equation. Third step that we'll get to is going to come from periodic table. And you only use the full PEP if you're doing grams to grams. For like a problem up here, we didn't have that grams to mole step. So this first step was really just your equation and then your periodic table is where that information came from. So coming back down to this one, well, what is our trade ratio of sodium hydroxide to copper chloride? Well, I have to trade 2 moles of sodium hydroxide, again coming from my equation, for every, and I'm going to just switch the color back to red, for every 1 mole of copper chloride. Well, again, real world, you can't get down and measure. You can't count those copper chlorides. So that's why we rely on the mass. So I need to figure out, well, how much does one of those copper chlorides weigh? Well, that's going to be the mass of 1 copper, which looking at our periodic table, copper is 63.55. And then we can look at, we would need 2 chlorines, 35.45. You add all that together. Some of you like to see work, so I'll just kind of show that here. 2 times 34.45. And you would find that the mass of copper chloride is 135. I'm sorry, not 135. 134.45 grams copper chloride. And then if we solve for that, remember what this number is going to tell us now is how much of this copper chloride is needed in order to use up all of that sodium hydroxide. And so we would find that we would need 2.43 grams of copper chloride. Well, that actually tells us our answer right there, because remember, if we compare these numbers, we have 2.88 grams of copper chloride. We need 2.43. So again, what that tells us here is that sodium hydroxide must be our limiter. Because let's say that this number was a lot larger. Let's say that this was 6 grams copper chloride. Well, in order to use up all of our 1.45, if we needed 6 grams and we only had 2.88, well, that would have meant copper chloride was our limiter. Coming down to the next question then, it says based on your limiting reactant above, okay, so I know that I'm going to have to start with my 1.45 grams sodium hydroxide because that was my limiter. How many grams of copper hydroxide can I produce? Well, nice thing is, these first steps are going to be the same. I always pretty much have to go to moles. I have to do a trading ratio. I can't compare grams to grams. So I'm really just pulling in the same steps from above. Now though, I'm not going to copper chloride, I'm actually going to copper hydroxide. So I'm going to this product over here. Well, I can still trade 2 sodium hydroxides for 1 copper hydroxide. So 2 moles of sodium hydroxide for every 1 mole of copper hydroxide. And then again, I'm going to need to figure out that mass. So how much does 1 copper hydroxide weigh? And to do that, we're going to take our masses again, 63.55 plus 2 times oxygen's mass we can actually see on the periodic table here is 16. Plus we're going to have oxygen. And if we add all of that together, we'll find that the mass of copper hydroxide is 97.57 grams. So then we go through, we do the math, and we find that we would be able, if we perfectly used up all 1.45 grams of sodium hydroxide, we could produce 1.77 grams of copper hydroxide. And since we started with 3 sig figs, I can go ahead and keep 3 sig figs in my answer. And then the last one, again, we're just going to build it off this same thing, and these first steps are going to be the same, but notice I actually wanted to make sure I got you a question like this. If you had 1.45 grams of sodium hydroxide, how many molecules would you have? Well, remember, it's almost like this analogy that I think I gave you. I think the analogy I give is that, 1 brick equals 10,000 atoms. So if I asked you how many, atoms there were, or how many atoms there were, you'd be like, well, I need to know how many bricks. It's that same idea, except for instead of bricks, we're going to talk moles, and instead of 10,000, it's this number 6.02 times 10 to the 23rd. And really, 1 mole is 6.0 times 10 to the 23rd of anything. So the way that I'm going to solve this, a lot of my work is going to be the exact same. I'm going to take my 1.45 grams sodium hydroxide. Well, I need to get that to moles. I need to know how many bricks. So I'm just going to use that same process I have. 40.0 grams sodium hydroxide per 1 mole of sodium hydroxide. And now all I'm going to do is I'm going to use this equivalence. Oh, well, I know 1 mole of anything is equal to 6.02 times 10 to the 23rd. Anything. So I can take that 1 mole of sodium hydroxide is equal to 6.02 times 10 to the 23rd molecules sodium hydroxide. And so if we plug that in, we'll get a final answer here of, and I have 3 sig figs, 2.18 times 10 to the 23rd, I'm sorry, to the 22nd molecules of NaOH. And there we go. That is how you're going to solve this. Thank you for learning with me today.